Good morning everyone. Welcome to Competitive Concepts by Lakshmi Prashanti. In this video, I would like to explain about what are the rules we have to follow to assign the oxidation state for the element which are present in the compound to find out the unknown element present in a compound. Okay. So there are some rules. For example, in my previous video, I explained about KMnO4. To find out the oxidation state of manganese. We don't know the oxidation state of manganese. Potassium, alkali metals +1, oxygen -2. Why? Because -2, it requires 2 more electrons to get the octet configuration. Here, to calculate the manganese oxidation state, we have to put X for the element which we have to find out the oxidation state. So +1 potassium plus manganese X plus 4 oxygens, each oxygen having -2 oxidation state. The sum of all the oxidation states of the elements present in a compound should be equal to 0. Why? Because it is not having any charge. That's why the sum should be 0. So x1 plus x minus 8 is equal to 0, x minus 7 is equal to 0, x is equal to +7. So in this way we have to find out the unknown element oxidation state. But here we have to write the oxidation state of potassium for +1 and oxygen for -2. We have to know some rules. That rules I will explain in this video. Okay, once go through this video, watch till the end. The first rule is, in elements in the free or uncombined state, each atom bears an oxidation state of 0. In elements in the free or uncombined state, uncombined means it should not combine with any other element. For example, uncombined state means sodium. It can exist as a single element. Magnesium, aluminium, like this. All these elements are present in uncombined state. That means it is not combining with any other element here. So here the oxidation state of sodium is 0, magnesium is 0, aluminium is 0. And in the free state means hydrogen can be exist in its molecular form in this nature, and chlorine Cl2 form, nitrogen N2, ozone O3, phosphorus P4, sulfur S8. Here all these molecules which are present in nature in molecular form, but in native state, in its original state, here also the oxidation state is equal to 0. Okay, this is the meaning of the first point. So once again, see the first point. The elements in the free state or in uncombined state, each atom bears an oxidation state of 0. That is the first point. And next one, for ions composed of only one atom, oxidation number is equal to charge on the ion. For ions composed of only one atom, the oxidation number of that ion should be equal to charge on the ion. For example, Na+. Here the oxidation number of sodium is equal to the charge on the ion. Cl-. Here the oxidation number is equal to -1. O2-. That means here the oxidation number is equal to -2. And N-3. Here the oxidation number is equal to -3. For ions composed of only one atom, the oxidation number of the particular atom is equal to charge on the ion. Next point is, the algebraic sum of the oxidation numbers of all the atoms in a compound is equal to 0. For example, in case of KMnO4, what I explained in previously, here there is no oxidation state or charge above this compound. So sum of the oxidation states of all the elements which are present in this compound, the oxidation numbers sum should be equal to 0. Potassium +1, manganese X plus 4 into oxygen -2. The sum should be equal to 0. So then what will be the manganese oxidation number? +7 plus -8 here. So the sum is equal to 0. That means the sum of the oxidation numbers of all the atoms in a compound should be equal to 0. Okay, that is the meaning of this rule. See this point, in case of polyatomic ion, the algebraic sum of all the oxidation numbers of atoms of the ion must equal to the charge on the ion. For example, polyatomic ion means sulfate ion SO4 minus 2. That means in case of polyatomic, more number of atoms, 1 sulfur and 4 oxygens. The algebraic sum of all the oxidation numbers of atoms of the ion must equal to the charge on the ion. That means here sulfur X plus 4 into minus 2, oxidation state of oxygen minus 2. The sum should be equal to minus 2. Here X should be what? X minus 8 is equal to minus 2. That means X is equal to minus 8 if it comes towards this side, plus 8. Then automatically plus 6. That means here plus 6 plus 4 into minus 2 is equal to minus 2. Right? So, the sum of the oxidation states of all the atoms present in the polyatomic ion, sum of oxidation states will be equal to the charge on the ion. That is in case of polyatomic ion. But in case of compound, it should be equal to 0. Okay. For alkali metals means what? Group 1 elements. Alkali metals oxidation state is equal to +1, and alkaline earth metals. Generally, alkali metals, that means group 1 elements, that if it lose 1 electron, they can attain the octet configuration. For general alkali metals, oxidation state is +1. Alkaline earth metals, oxidation state is +2. And boron family, that means 13 group elements, it is having +3 oxidation state. And the next rule is for oxygen. For oxygen, the oxidation state generally is, for oxygen, general oxidation state is equal to -2. Why? Because it is based on the number of electrons it has to gain to get the octet configuration. But there are some exceptions. That means in case of peroxides, that means oxygen directly linked with another oxygen atom. In that case, oxygen is having oxidation state -1. For example, H2O2, hydrogen peroxide. In that case, why? Because here hydrogen is having +1 charge. How many hydrogens? 2. And 2 oxygens we have to find out 0. Sum should be equal to 0. So 2x plus 2 is equal to 0. 2x is equal to -2. X is equal to, both are cancelled, then -1. Right? X means oxygen oxidation state in case of peroxide is -1. And in the case of superoxides, when if the oxygen is present in superoxides, then oxidation state of oxygen is -1/2. For example, KO2, right? Potassium, KO2. Here potassium we know that is alkali metal, +1 and +2 into oxygens, that should be equal to the sum of the oxidation numbers of all the atoms in a compound should be equal to 0. So 2x plus 1 is equal to 0. That means 2x is equal to -1. Right? Then x is equal to what? X is equal to -1/2. And the next rule is for hydrogen. So in generally for hydrogen, the oxidation state is equal to +1. Okay, but exception is -1. -1 when hydrogen exhibit means when it is bonded to highly electropositive elements. Generally it is having positive oxidation state, but it can exhibit negative oxidation state when it combined with highly electropositive element. That means when it occurs as hydrides. That means lithium hydride or sodium hydride, like this, if they exist, then this is a highly electropositive element, metallic element, group 1 element, +1. Then automatically it should be equal to -1. Then only the sum should be equal to 0. Okay. So here we given 8 rules, and next the last is for fluorine. We know that is a highly electronegative element. It is having -1 oxidation state. But next chlorine, bromine, iodine, these are also halogens. These are also having -1 oxidation state. But they can exhibit positive oxidation state. When they can exhibit positive oxidation state? When these chlorine, bromine, iodine combines with another electronegative element. For example, oxoanions and oxocations, Cl2O3, like this. In this way, chlorine is electronegative element, but when compared to oxygen, this is less electronegative. Then chlorine exhibit positive oxidation state and oxygen exhibit negative oxidation state. Okay, these are the rules we have to follow. Okay, and in generally metals means positive oxidation state, and non-metals are having positive and negative oxidation state. In case of transition elements, that means D block, they can exhibit several oxidation states. Okay. So these are the rules which we have to follow while assigning the oxidation state, or while identifying an unknown element oxidation state. We have to know some rules and exceptions cases. So watch till the end and share with your friends, like and subscribe. Thank you.